This is practice problem number 3 from lesson 13, solving systems of equations, and this is unit 4. So in problem 3, you're supposed to solve this system of equations, and that means find the same value of x, so the same x coordinate that results in the same y coordinate for both equations. That gives you the same coordinate pair, which is a point on the graph, and so the graph for each of these lines goes through that point. And so that's the intersection of the graph of these lines. But before we do the algebra to figure out what the value of x is, let's reason through what that answer is. What's the value of x and what's the value of y? And so remember, we can start off by calculating the difference in the y-intercepts. So 9 is the y-intercept for this equation, and a -3 is the y-intercept for this equation. So that difference is 9 minus -3 is equal to 12 units. So these graphs cross the y-axis 12 units apart. And they're moving at a rate of 4 units along the y-axis for each unit of x, or a -2 units along the y-axis for each unit of x. And so that difference in the slopes, these are the rates or the slopes, that difference is their combined rate. How quickly are they moving together? Are those graphs moving together? And that's 4 minus a -2 equals 6 units of y for every 1 unit of x. So they're moving together at that rate, 6 units per unit x. So here's a graph. The y-intercepts are 12 units apart, and these graphs are moving together towards each other at 6 units y per each unit x. So if I go over 1 unit of x, these points now are 6 units apart. 1, 2, 3, 4, 5, 6. You go over another unit of x, now these graphs intersect because now they are moving together at 6 units for each unit x. So they're 12 units apart, now they're 6 units apart, and now they intersect. So 12 units of y, so how many of those 6 units can you get out of 12 units? So you're moving together at 6 units each time. So how many times can you do that? And the answer is 2 times. So 2 units of x, so x is equal to 2. And so now you can use that x coordinate of 2 to calculate what the y coordinate is. So take either expression. If I take this one right here, y equals 4x minus a -3, or minus 3, replace x with 2. 4 times 2 is 8. 8 minus 3 is 5. So this point right here is the only point that is shared by both graphs, is the solution to both equations. They share this point, this coordinate pair, same x coordinate and the same y coordinate for both. So now if we solve this system algebraically, you're going to see these calculations as we go through the algebra. You're going to see a calculation of the difference in the y-intercepts, and a calculation of the difference in the slopes. And also you're going to see the division. So I'm going to rewrite this first equation as 4x plus a -3. It's the same thing. This is subtracting a +3, so use the inverse operation and the additive inverse. It doesn't change the problem. It equals a -2x plus 9. And so the first step is to find the difference in the y-intercepts by getting rid of this -3. So 4x plus -3 minus -3, so this is going to become 0, equals a -2x plus 9 minus a -3. Well, this calculation right here is the difference in the y-intercepts. It is this same calculation over here. So this is going to be 12. And then the next step is to remove this -2x from the right side by subtracting -2x. So 4x minus a -2x is equal to a -2x minus a -2x. This becomes 0, left with 12, and this is the difference in the slopes right here. 4 minus a -2 is equal to 6. That's this calculation right here. So then you divide. How many 6's can I get out of 12? Because this becomes just x. So 6 divided by 6, this is 1, so this becomes x. And now you have 12 units apart. They're moving together 6 units at a time. So how many of those 6 units can I get out of those 12 units? That answer is 2. X equals 2 units to close that gap. Then again, use either expression, replace x with 2. 8 minus 3 is equal to 5. And so you get the same point. You have to get the same point. The x-coordinate is 2, and the y-coordinate is 5, which gives this coordinate pair, this point, which is shared by both graphs and shared by both equations.